Cataclysms may have caused extinctions and disasters, but they have also shaped the Earth and produced an environment in which human life could flourish. The air breathable, the seas are warm, climate mild, the ice rooted firmly at the poles. In fact, a geological truce. But that truce may be coming to an end. The forces that drive the Earth are impervious to our needs. With man so widely spread across the planet, cataclysms of nature will turn into human catastrophes. Every movement of the plates brings the danger of disaster nearer. "50 million years ago, the Asian and Indian plates were about to clash. Separated by a dying ocean, they collided with fantastic force. Neither would give way, and the land had only one way to go: up. This is the world's highest mountain range, the Himalayas. This entire area was uplifted from sea level to over 5 miles high in less than 30 million years. How do the scientists know? From the evidence of the rocks.
There's dramatic evidence for this uplift right in the face of Everest in Lhotse. The famous yellow band that you can see cutting across is actually a marine limestone. It was formed in the bottom of the ocean.
So 50 million years ago, the tops of these mountains were at the bottom of the sea. It's hard to believe.
We have similar evidence from Tibet, where we find things like this, ammonite fossils of marine creatures at now more than 4,000 meters above sea level. Certainly these tell us that plate tectonics supplies enough force to lift things from the bottom of the ocean all the way to here, the top of the world.
This is the only place where two continental plates are colliding on such a scale, and the mountains are still growing as a result of the tectonic squeeze. Even Everest is still stretching skywards.
I can't quite feel it, just standing here on a piece of Himalayan rock. The Earth that I'm standing on is actually moving up at about 10 millimeters a year, and is moving to the north at an even faster rate than that, maybe 15 millimeters a year. The reason why we can measure this is because of these fantastic receivers. They use 4 satellites up in the sky above me to solve a simple triangulation problem, but they're so accurate that they can give me something like 1 millimeter of accuracy in the horizontal and more like 5 millimeters in the vertical. That way I can come back year after year. We can see that this point drilled into this rock that's attached somehow to the root of these mountains and the continental plate that they're stuck to is moving.
There is another way that Rebecca Bendick and her colleagues can discover exactly how the Himalayas are growing. They have found an area in the foothills, 10 miles south of the highest peaks, that is rising even faster than the mountains. The clues to the uplift are found in the fast-flowing rivers that tumble through these valleys.
You can think of this river in 2 different ways. One is that this land is still and the river's cutting down. The other way, and I think a better way to think about it, is that the river is staying at sort of a constant position with respect to the sea, way off in the Bay of Bengal, and the earth around it is rising up. So in order for the river to stay in one place, it needs to cut down, like a knife, through butter.
But in some places, the river cannot cut quickly enough to maintain its natural equilibrium. Here, the land rises faster than the river erodes it down, and a giant step is formed, creating white water and rapids.
We're looking for places where the river is a lot steeper than its average gradient anywhere along a stretch. Those steeper places are corresponding to places where the uplift is quick, so quick that the river can't keep up. This will give us clues about places to come back and do more intensive GPS research to try to pin down the uplift rates.
It seems this area is continuing to rise faster than the high peaks. One day, this riverbed will be taller than Everest.
Taking data in this way is dangerous, but with a little bit of care, it's definitely worth the good information that we get about the Earth.
That information is vital for the 100 million people living in the danger zone round the Himalayas. Earthquakes are common. 30,000 people have been killed in the last century alone. This area has been quiet for 700 years, and a major quake is long overdue. Rebecca Bendick's monitoring shows that the convergence of India and China at 2 inches a year is setting up immense stresses which must eventually be released. A solar-powered GPS station will send back information 24 hours a day, hopefully giving an early warning.
The crux of the matter is that we need to know how that total convergence is partitioned over the faults. If all 60 millimeters of convergence has to be accommodated in one place, on one fault, on this one narrow line, then the earthquakes we have there are going to be big and they're going to happen often. But if instead all of that strain is accommodated on several different faults, something like an accordion, then each fault can only be expected to fail less frequently and less violently.
Earthquakes are appallingly destructive to human life, but for scientists, they have their uses. The seismic waves are like sonar. By listening as they pass through the Earth, a picture can be built up of a place no one will ever see. First, the waves race through the crust, the skin on the planet's surface. In some places, only 4 miles separate us from the intolerable heat of the mantle and interior of the Earth. 3,000 miles down in the core itself, the temperature reaches an unimaginable 7,000 degrees. It is the ultimate nuclear reactor, the engine driving the planet. Cooling comes by gigantic convection currents in the mantle, and it's that heat rising with the hot magma that forces the tectonic plates to shift. Earthquakes are a ferocious manifestation of the power of the Earth's plates. More than 1.5 million people have been killed by them in this century alone. Most quakes occur along fault lines where the plates grind together. Scientists can't tell us when this terrifying destruction is likely to occur. They can only tell us why.
You can't have an earthquake without a fault. And I'm standing right now on what is perhaps the most famous fault in the world, the San Andreas Fault, that extends from Mexico down south, way up to Oregon in the north. This is one of the few places in the world where you can stand with one foot on one tectonic plate and one on another. In other words, this ground here is attached to New York and Iceland. The ground here is attached to Hawaii and Japan.
At this part of the fault, the plates are stuck. They should be moving at 2 inches a year. The last earthquake was 100 years ago, and the fault is storing up the unreleased energy. The longer the plates are stuck together, the larger the ensuing tremor will be. Further north, the plates are sliding smoothly past each other. The evidence is clear from the way this fence has buckled.
We're on the San Andreas Fault south of San Francisco, and this is an interesting part of the fault zone because the 1906 earthquake ruptured through this field here across the road and stopped about here. But this fence was built after the earthquake. In other words, the fault has been sliding ever since then. So what's going on here exactly? And you can see here, there are cracks in the road. These have grown since I was last here, all over the road here. And I have a machine in the field, and I am absolutely dying to see what it says. Let's go have a look. What we have in the field here is a creep meter. A creep meter measures creep on the fault, the creep that's caused the offset of this fence. It consists of a rod that is attached firmly to that side of the fault, passes through the fault into a box here. Inside the box is a computer that's been measuring things. Now, I have to be rather careful because sometimes there are snakes here. Oh, not this time. Good. What's left are black widows and ants. All right. So here is a computer that's been measuring for a year. It records the movement of the fault every minute to about 1/1000th of an inch. So let's download the data and have a look. There we are. Well, it looks as though we've had about 7 millimeters of creep, like this site usually has. But the interesting thing is it's all limited to a very short period of time. If you look here, you can see the fault has been locked for most of the year, but suddenly, in the middle of September, it takes off and it slips about 5 millimeters in the space of a couple of hours, and it continues to slip in the next few days. In other words, a whole year's budget of slip occurs within the space of a few days. That might not seem much, 5 millimeters, but it's affecting a long section of the fault, maybe 5 miles long, involving millions of tons of rock. Now, it really doesn't matter here. This is a nice sort of field, there aren't any people, but further north, this creep process and the things that are happening beneath the earth are far more sinister.
San Francisco is home to 2.5 million people and lies right on the Hayward Fault. In its 200 years history, it's been hit by 3 killer quakes. Scientists know the slippage on the fault has begun to slow down, a warning sign. But when will it strike? In 1989, 67 people died in an earthquake at Loma Prieta, part of San Francisco. No one had foreseen it coming.
Earthquakes are an inevitable consequence of the movement of plates. We cannot stop plate motions, and therefore we cannot stop earthquakes. But we can begin to live with them. And the first thing we must learn to do is to build our cities better.
As the world population grows, so does the danger. There are now more than 100 cities around the world with population of over 2 million, and more than half of those are on plate boundaries or places where earthquakes have already struck. Los Angeles is the most vulnerable of all the places on the West Coast fault line. This stretch of road shows why. Not only is it on the San Andreas, but here the fault is being forced round a bend. Where this happens, the rocks get compressed with enormous force. They cannot go sideways, so they go up. The movement curls the rocks, bends, folds, and crunches them, faulting and distorting the land. Many faults never surface, although scientists know they're there. Known as blind faults, they are probably the most dangerous of all.
You come down the hills here until you hit the plains, the flat area where 11 million people live, and across there, far behind the tall buildings of downtown LA, we think there's a fault right there, right underneath the center of LA.
At 4:24 in the morning on the 17th of January 1994, the suburb of Northridge was shaken to its foundations. A blind fault had fractured 11 miles down, causing some of the most intense ground shaking ever recorded. Ground acceleration exceeded gravity, throwing buildings, furniture, and people into the air. 61 died, 9,000 were injured. Buildings, roads, and bridges were destroyed. Damages ran to $20 billion, and the aftershocks went on for days.
When it goes, like Northridge did, seismic waves are spread all over the basin, big ripples shaking all the buildings. It's exaggerated where the sediments are concentrated in the basin here, because the basin's completely flat, and it's flat because it's washed in there from the mountains by water, so we have saturated sediments.
When the sand and water combination is shaken together, it turns liquid for 5 minutes after the shocks, causing tall buildings to destabilize and fall. It's called liquefaction and presents an enormous and unpredictable danger. And there is another geological trap waiting to spring. The San Gabriel Mountains stretch from the San Andreas Fault down to the Los Angeles Basin. As the earthquakes crack and shudder along the faults, they are being inched towards the city. Here the fault is pink and the mountains in yellow. This is how they have swung so far. In some distant geological future, they will cover the city completely. What does the geological future look like? What clues are hidden in the mountains, deserts, and seas? It's difficult to grasp that the march of the Earth is unstoppable.
We've been very lucky because modern society has actually developed at a time when very little has been happening geologically. So we've been in a period of geological quiescence. Now this isn't going to last. We know that there are going to be major global catastrophes occurring in the future, gigantic tsunami, big volcanic eruptions, more impact events. And on that basis, we know that we're all living on this planet simply by geological consent.
Ice is crucial in helping to keep the Earth's climate mild enough for life to survive. But worldwide, the temperature is rising, and the ice is melting. If this keeps happening, sea levels will rise. A rise of only 15 inches would spell catastrophe for low-lying countries and low-lying cities.
Major sea level rise in itself may be catastrophic for the planet, but actually there are unexpected effects as well, and that is that rising sea levels may trigger volcanic eruptions. We know this because we've been looking at the relationship between changing sea levels and volcanic eruptions in the Ice Age, when we had changes of 100 or 200 meters in sea level over a few tens of thousands of years.
Maguire's new work on Etna seems to show that the more rapidly sea level rises or falls, the more violently the volcano tends to explode.
When sea levels rise around coastal volcanoes such as Etna, they have a rather interesting effect. If you imagine the volcano sitting on a plate with Etna here, if you then load the other half of the plate by sea level change of 100 meters or so, it has the effect of bending it. And what that does is set up tensional stresses within the volcano, and any magma sitting there will burst its way out in the form of an explosive eruption.
In modern times, we haven't really experienced the full terror of a volcanic catastrophe. If Bill Maguire's theory is right, such an event could hurry in the new ice age, because nature can wield a two-edged sword. Rising sea levels could cause volcanoes to erupt, spewing debris and sulfur into the atmosphere. That will cut out the heat from the sun, so the Earth will cool. That will make the ice form again, freezing the oceans so sea levels drop once more. And that sudden fall may trigger more volcanic activity, pumping more material into the atmosphere, making the Earth even colder, ushering in the dark and the ice and the long winter. There is evidence for many ice ages during Earth's history, but the last full and most severe one began 45 million years ago, just as the Himalayas were being formed. One theory attributes the dramatic cooling to this tectonic turmoil. The mountains are littered with limestone rocks and rubble. This debris would combine with rain and carbon dioxide in the air in a chemical reaction which removed millions of tons of the gas from the atmosphere. With less greenhouse gas to keep it warm, the entire planet would cool, triggering the Ice Age. At the edge of the vast ice sheets, Immense glaciers advanced relentlessly. Nothing could resist as they raced forward at speeds of up to 10 feet per day. The ice covered more land, so more of the sun's heat was reflected back into space, chilling the planet further. At its coldest, Earth was covered by 3 times the volume of ice on the planet today. This ice locked the water away, trapping it on the land. With less available water, the world's sea level dropped by 425 feet. Today, the Caribbean island of Grand Bahama holds the clearest clues to the dramatic change in past sea levels. Microbiologist Steffi Schwab has been piecing the story together. Hidden deep in a mosquito-ridden mangrove swamp is an unlikely entrance to a mysterious ancient world.
These caves have a story to tell concerning past sea level fluctuation and past interglacial and glacial periods. What makes these caves particularly exciting is that they are one of the last unexplored frontiers, and they turned out to be one of the world's largest and longest known cave systems. We move from the entrance into a very large cathedral room where we can see the ceiling comes up to what we commonly call these cave systems, which is a blue hole. You always find, when you go into these large cathedral rooms, a very large rock pile in the center. And usually the collapse happens when the water is no longer in the cave, supporting the ceiling. I'm now swimming through what is called a mixing zone, and this is where the fresh water mixes with the seawater and causes what we call a shimmer. This mixing zone is responsible for aggressively attacking the wall rock. It's like soft cheese. Normally, limestone could not be removed with your finger. You would need a rock hammer and a chisel. This is how we know that the caves have formed hundreds of thousands of years ago. But we also know by evidence that we have found that the caves have been dry in the past. 20 meters down further into the cave system are these bat droppings that have been fossilized. And we know the only way that this can happen is when the caves are dry, because bats do not swim. And when bats roost in the ceiling, the droppings collect on the rock and they become very hard. Deeper into the cave system, we find another bit of evidence, and that is this red Saharan dust, which gets blown into the stratosphere during frequent storms which occur in the Sahara Desert, and will actually find its way into these caves. Most likely it's happened during periods when the cave was dry. The final bit of evidence which supports the fact that the caves have been dry are these beautiful stalactite and stalagmite gardens that we find at 28 meters plus. Stalactites and stalagmites form during the ice ages and have formed over a period of hundreds and thousands of years. What happens is the water is frozen in the ice caps on the poles, sea level drops, and the caves become dry. And usually during ice ages, it rains a great deal more in the tropical regions of the world. This rainwater percolates through the bedrock or the sealing rock and dissolves the rock that's there, and it comes out in the drip water and crystallizes, just like an icicle. And basically, these are rock icicles.
The Ice Ages affected and shaped the landscapes, but sometimes the clues are so gigantic it's hard to recognize them. In Washington State, in the Grand Coulee Canyon, are the channeled scablands. For years, a succession of scientists tried to work out what could have caused erosion on this scale. USGS scientist Richard Waite is the latest investigator.
This rock, the size of a 3-story house, looks like it's part of the bedrock. Part of this basalt that forms this vast landscape. But the structure in the basalt is horizontal, as you can see, whereas the structure in this rock is vertical. In other words, this big rock has been moved. But the biggest clue in the landscape is the landscape itself. This gorge is carved in basalt, one of the hardest of rocks. It ends in a sheer cliff, 400 feet high, and it's in the shape of an enormous horseshoe. It's like the gorge below Niagara Falls. But this, Dry Falls, is fully 2 Niagaras high and 3 wide.
Waite is continuing the work begun by geologist J. Harlan Bretz in 1923. Bretz was the first to say that this entire landscape was a gigantic riverbed formed by 3,000 square miles of the Columbia Plateau being swept away. No one believed him because the scale was so huge, but he was certain that the only explanation for this scale of damage was an enormous flood. The whole area was obliterated and changed forever as the torrent flooded through. Even on the top of the cliffs, the water was over 100 feet deep. The basalt cliffs are amongst the hardest structures found in nature. Resistant to weathering and erosion, these walls could only have been cut by an enormous body of water. One by one, these columns of frozen lava were quarried from the rock face and carried away by the raging torrent, causing the wall to retreat and the cataract to widen. So it was accepted that this is how the channeled scablands were shaped. But an important part of the mystery remained. Just where could all that colossal, earth-shattering volume of water have come from?
100 miles to the east, geologist Joseph T. Pardee had described an enormous Ice Age lake, Glacial Lake Missoula. This lake held in some 600 cubic miles of water. 600 cubic miles is all of present-day Lake Erie, plus all Lake Ontario. The lake was held in by an ice dam that had crossed the Clark Fork River and dammed it. The lake rose 2,000 feet deep against the side of the ice dam, but there was no evidence to link the lake with the channel scabland. In 1939, Pardee discovered a series of giant ripples. These are like sand ripples on the beach, but they are of enormous size, hundreds of feet apart, 10 feet high and more, and they're composed of gravel. Such a feature could only indicate a swift outflow from Glacial Lake Missoula.
The gigantic ice dam held back the water until it reached a critical level. When it was 1,800 feet deep, the pressure of the water was so immense that it forced its way through the base of the ice dam. Having found a weakness, the icy waters raced on, widening the split and weakening the dam catastrophically. The waters of the entire lake were released in a devastating discharge.
This discharge was 10 times the flow of all the world's rivers. That's almost beyond belief.
In 1926, a freak flood created a 100-foot deep canyon. 200 miles away in the Walla Walla Valley. It revealed many layers of silt. Waite realized that this area must have been in the path of the great floodwaters that formed the channeled scablands.
This white layer here is an ash that we know is from Mount St. Helens. We've analyzed it chemically, mineralogically, and it clearly came from Mount St. Helens. And we know its date. By radiocarbon dating, we know that this is 15,000 years old, approximately. Therefore, we have a beautiful timeline running through this section of 15,000 years.
The ash could only have fallen after the flood had passed and the sediments settled, yet it's covered by many layers of sediments, 39 in all. This was the final piece of evidence that explained the creation of the scablands. The catastrophic outburst flood must have happened time and again. Once each flood had left its mark, the vast glacial dam would advance and the waters of Lake Missoula would start to rise again, continuing the cycle of flood followed by calm. Only when the time of the ice was over did the flood stop. The change from Ice Age to warmer times is governed by how close the Earth is to the Sun. Every 100,000 years, the shape of the Earth's orbit around the Sun changes. This has led some scientists to wonder if the recurring cycle of catastrophe and extinctions on our planet is governed by extraterrestrial forces.
Mass extinctions and the catastrophes that cause them seem to follow a periodicity of about 30 million years. It's that cycle that suggests that the cause of a catastrophe lies outside the Earth. On a clear night here in Africa or in other places where you can see the night sky, we can see astronomical evidence for the cause of these geological catastrophes every 30 million years. Our solar system is on a voyage through the disk-shaped Milky Way galaxy. Every 30 million years, we pass through the densest part of the galactic disk. During that time, the comets of our solar system can become disturbed and fall inward toward the inner planets. During this period, the Earth is more likely to be impacted. This cycle may explain the catastrophic history of the Earth. The last major mass extinction was 35 million years ago. We're in the densest part of the galactic disk now, and the next mass extinction may include us.
Asteroids are a very real threat. They even formed our own moon. Soon after its violent beginning, our planet suffered a ferocious assault. A rogue asteroid bigger than Mars smashed into it with enough power to blast much of the Earth's surface into space. The debris was drawn together by gravitational forces and formed a proto-lunar disk. From that, the new moon grew rapidly, sweeping up the debris in orbit around the Earth. Computer models suggest it only took a year for the fragments in orbit to coalesce and form a single moon.
This is the Clark Telescope at the Lowell Observatory in Flagstaff, Arizona. It's a telescope that was used to take pictures of the moon in preparation for the Apollo moon landings. To see the moon tonight, we need the telescope up in this position. And we can make some fine adjustments. The density of the craters on the moon's surface was measured using the photographs taken by the Clark Telescope. What's more, the astronauts visited some of these regions in their 6 Apollo missions.
Man, does this thing have steep walls. They said 60 degrees. Now, I tell you, I can't see to the bottom of it, and I'm as close to the edge as I'm going to get. That's the truth. I can't believe we came over those mountains.
The largest impact feature on the moon, the Imbrium Basin, is more than 1,000 kilometers across and was produced by the impact of a comet or asteroid more than 100 kilometers across.
Yeah, those are pretty big mountains to fly over, aren't they?
The basin is surrounded by mountains more than 5 miles high. This is where the Apollo 15 astronauts landed and took samples. They show that these mountains are not like the mountains on the Earth, but they're piles of rubble, fragmented rock thrown out by this giant impact.
Look at at that. Guess what we just found? I think we found what we came for. Crystal rock, huh? Yes, sir. You better believe it.
The pristine moon rocks that were brought back by the Apollo astronauts have been radiometrically dated and studied, and they show that impact has been an important process in the formation and evolution of the Earth-like planets. What's more, the radiometric dating of the rocks has shown that the moon underwent a hellish bombardment between 4.5 and 4 billion years ago. After that time, the bombardment died down. By that time, most of the asteroids moving around in the inner solar system had collided with the planets, and the process of formation of the planets was over.
200 space rocks large enough to cause global devastation are known to be on Earth-crossing orbits, and there may be many more.
Here in Namibia, meteorites have always been considered special objects, worthy of veneration. These meteorites have been put on display as a centerpiece of the city. The impact of small iron meteorites like this would have little effect on the Earth as a whole. But the impact of a much larger object, a 6-mile diameter asteroid or comet, would cause a mass extinction, as we know from the geological record. The impact of a 1/4-mile diameter object, like the one that just missed the Earth in 1996, would cause widespread destruction. A hit in the ocean would cause tsunami that would devastate coastal cities. And a hit on land would produce a dust veil that would produce nuclear winter-like conditions that would threaten civilization as a whole.
The geological record shows impacts brought catastrophe and devastation which wiped out many species. There have been 5 key mass extinctions in Earth's history. Best known are the dinosaurs. Why did they simply disappear from the face of the Earth? India may provide the answer. 65 million years ago, it was still an island drifting towards Asia. This was when the layered landscapes of the Deccan Traps were created. A great volcanic rift spewed out 500,000 square miles of lava. Layer after layer of lava lies on the land in places up to 8,000 feet thick. Some scientists believe that the scale of this volcanic activity was so great it killed off the dinosaurs. Professor Michael Rampino thinks the traps were triggered by an extraterrestrial visitor.
This is the Hoba iron meteorite in Namibia. It's the largest meteorite known on Earth. And like most meteorites, it contains the rare element iridium. And iridium has proven to be the clue, the connection, between the impact event and the extinction of the dinosaurs.
Iridium is found near impact craters, but is extremely rare elsewhere in the Earth's crust. At these craters, the levels of iridium are 10,000 times higher than normal. Such high concentrations have been found in the sedimentary record all over the world at a consistent date of 65 million years ago. Recently, a crater more than 110 miles wide was detected off the coast of Mexico's Yucatan Peninsula. It too was created 65 million years ago. It was formed by a 10-mile-wide cosmic killer which closed on Earth at more than 60,000 miles an hour. It struck with the violence of the world's entire nuclear arsenal exploding 1,000 times over. It sent out a ferocious fireball engulfing the land for thousands of miles around. Enormous fires raged for months, destroying everything in their path.
The impact may have had other catastrophic effects as well. The force was so great that shock waves went out from the point of impact in Mexico around the world and focused and concentrated at the exact opposite point of the Earth, in the Indian Ocean.
The exact opposite point in those days was the island of India, and Rampino believes the violent volcanic eruptions which created the Deccan Traps was triggered by the meteorite. The effects of the impact explosion and the volcanic flood poured millions of tons of dust and ash into the air, plunging the world into darkness. Nitrogen, sulfur, and oxygen in the atmosphere combined to form acid rain as the Earth cooled. this cosmic winter, 75% of all living things perished. When the skies cleared, the dinosaurs had gone. Human time span is so short, it's hard to understand that we will be undone by forces that play out over millions of years. In Utah, the shells of countless millions of marine creatures which lived and died here have been exposed where the San Juan River creates a great tear in the Earth's crust. The river has revealed a lost world. 200 million years ago, the shallow seas once lapped the shores of the giant supercontinent Pangaea, which stretched unbroken from pole to pole. 50 million years ago, this entire region underwent a cataclysmic change. Erosion began relentlessly stripping away layer upon layer of rock. The tectonic forces which squeezed, compressed, and lifted the land were locked in an endless battle with erosional forces, carving fantastic landscapes. Water is the strongest force of all. It cuts through solid rock to create deep canyons. With terrible patience, it will scour away the stone and shape the rocks. One day, in an unimaginably distant future, Antelope Slot Canyon will be as wide and as deep as the Grand Canyon itself. The 1,000-foot-high sandstone pillars, buttes, and mesas that rise above the plains are the memorials to millions of years of the geological battle. But they too will disappear. Nothing can withstand erosion. Sculpting the surface, gouging out the deepest ravines, cutting down the tallest mountains, nature finds its own equilibrium.
The small mining town of Colemanskop, abandoned just a few decades ago, is already being invaded by the sand dunes. Eventually, it'll be entirely covered. If we turn our back for one moment, the geological cycle of erosion and deposition will take over.
Professor Rampino knows from his work in the Namibian desert how the tectonic dance will end. Scientists may argue about the short and medium term, but the further ahead they look, the clearer the vision becomes.
The sand in this dry riverbed in Namibia is part of an endless cycle of erosion and deposition. The sand is formed by erosion of granite outcroppings and carried downstream by rivers to the coast and picked up by ocean currents, moved along the Namibian shore to form the long beaches of Namibia. Some of the sand is blown inland to form dunes. The sands can be consolidated into sandstone and then be eroded again to form new sands, part of a cycle from granite to sands to sandstone and back to sand again. On a human timescale, not much happens, but on a geological timescale, all that we have done and all that we have made will be destroyed.
So, at the end, Earth has no future. Through millennia to come, the unfamiliar continents will form and move on as the plates continue their wanderings. Rivers will change their courses, oceans will empty and fill, and mountains erode and rise again. But our sun is aging. In 5 billion years, it will run out of energy. As gravity tightens its grip, it will collapse on itself, the temperature rising to 100 million degrees. It will expand uncontrollably, engulfing Mars, Venus, and the Earth. The seas will boil away, the atmosphere evaporate as Earth becomes a charred ember. Then the sun will cease all nuclear fusion and die. It will be the end of our amazing Earth.